In this AndEngine tutorial, we're going to learn about Box2D, get our player Fred bouncing off walls and all that crazy stuff, so let's get to it. What's going on, guys? Like I said, we are going to be working with Box2D in this tutorial. Box2D is going to allow us to add all the physics to our scene, such as gravity, collisions. We're going to be able to define how heavy or the density of Fred, which is our main character. Also, if we want Fred to have friction or how high we want him to bounce off objects, all of that stuff is going to be included with Box2D. So the first thing that we need to do is add the physics world to our scene, and that's what it's actually called, is the physics world. And we're just going to call this physics world. And then we're going to define what our physics world is for this scene within our onCreateScene method. So let's go down here and we're going to define what that is, and we're just going to set it up to be a new physics world. And as you can see, it takes two values, a vector2 and a Boolean value, which allows it to sleep or not. I'm not going to talk much about the second parameter, but the first parameter is where the gravity is going, and it's going to be a vector2. And so we're just going to create a new vector2, and this will be our x and y value. And then for our second parameter, we're just going to set that to be false right now. I'll get into that later, not in this tutorial, but go ahead and add your import for vector2. And basically what this is saying is there's no gravity right now. There's no gravity pulling our objects in the left direction or the x direction or the vertical direction, which is our y direction. But what we actually want to do is have the gravity be pulling the objects down to the bottom of the screen, and we're going to do that by relating to either a number like 9.81, which is the standard for gravity in meters per second squared, the acceleration of gravity. But there's also a class that handles some of these variables for us. It's called Sensor Manager. So we're going to relate to the Sensor Manager and hit dot, and as you can see, we can have different gravities, like gravity on the moon, gravity on Earth, a variety of different things here, and we're going to use one of those instead, so it's always somewhat consistent. Instead of just 9.81, it's 9.8066 something something something, whatever the gravity of Earth is. Basically what we're doing here is we're defining our x and y values. So let's say we had an x definition, which would be about 5 or something like that. We could set up a x pull in this direction and a y vector or whatever of 9.81, and then our gravity would pull us off to the right of the screen. This would be kind of the gravity direction of any objects in our screen. It'd pull it that way. Okay, hopefully that makes sense. But since we are just defining the x direction, we're just having a negative gravity here, and we aren't having gravity relate to the horizontal at all. So all of our objects will be pulled to the bottom of the screen. This is how it is in real life, in the world that we live. So that's kind of the definition of vector2. You'll see this quite often when we're working with physics, Box2D, all that stuff. So what we've done so far is kind of set up what our physical world will be. Now we have to attach that to our scene. So we're going to relate to our scene. We're going to say this.scene, and then we're going to say .register update handler. So basically what the engine does is it calls these update methods over and over and over again, so that we get a consistent animation and we move our objects in the x or the y direction according to whatever's happening, and we get this update every time. So now we have to register our physical world or physics world to this update handler, so it'll take into consideration gravity, and all of our other physics components that we want to attach to our scene will be registered now once we register our physical or physics world here. So if we run this, we still have the same screen as we did completing the last tutorial. That's because we only have a sprite. We only have like an image painted onto the screen. We don't have a body for this sprite for our player Fred, because once we give Fred a mass or a body, he'll be affected by gravity and he'll be pulled in the downward direction. So that's the next thing that we probably want to do. Again, we're going to do that within our onPopulateScene method down here. We've defined our sprite, what it is, all that stuff. We've attached it to the scene. But before we attach it to the scene, we're actually going to create our body of Fred. So we're going to say body equals, and we're going to relate to the physics factory, and we're going to say .create box body or circle body or a line body, polygon body, triangle. depending on what type of body it is, that's how it's going to relate to collisions and working with physics components. Again, Fred is a circle, so we're going to create a circle body. Click that. So the first parameter, as you can see here, it's looking for a physics world. We've created that. This is basically saying what realm of physics do we want our character or body to apply to, and we're going to do the physics world that we set up, the gravity and the x or the y direction. The next thing that we have to do is give it the shape of our character. Again, we've kind of created what our sprite's going to be here, and we're going to relate to that. So we're going to relate to the S player or a sprite, and then the next thing that we have to do is relate to the body type. And we'll get into body types later. There's three choices: dynamic, kinetic, or chromatic body type, and static body type. We'll get into these three later, but static body kind of just stays still. Even if there's gravity, it won't relate to gravity at all. Kinematic bodies will relate to some of the physics, but some of the forces applied on each body type will not be taken into consideration when there's collisions and stuff like that. As for now, we want all collisions, all forces to be applied to the body. We're going to choose dynamic body type, and again, I'll get into these other ones as well once we start using them. I just don't want to go too in depth in this tutorial without us needing to. And lastly, we have to define what type of fixture def we want, and we're going to create a new fixture definition here. I'm going to call this player fix, and maybe this will be a final, and this is going to come from the physics factory, and we're going to say create fixture definition. Density is going to be like how heavy Fred is. Essentially, it's going to be his mass per volume, and our elasticity will be like, hey, do we want Fred to bounce off a collision and go, well, in our example, do we want him to bounce off the ground and go back up to the same height, or do we want him to go a little bit less than his original height, or do we want him to go higher? And then also our friction here is, do we want friction to be relevant with Fred? So for density, we're going to give him 10.0f. These all have to be float values. For elasticity, we're going to say 1.0f, and that should roughly be about the same height. Sometimes we get some problems when working with AndEngine. It won't be exactly the same height. Over time, it'll get higher. We'll work with that later, but friction, we don't want friction to be applied to Fred. So now we've set up our player fixture, and we're going to relate to that as our fourth parameter here. And now we have set up Fred's body type. You can hit Control-Shift-O to add your imports. The next thing that we have to do is add some additional parameters for collisions and also interacting with physics for Fred. And we're going to do that after we attach him to the scene here, after we've attached our player. And we're going to relate to our physics world again, and we're going to say .register physics connector, and we're going to relate to a new physics connector because we haven't defined one yet. So we have a few different options to choose from with our physics connector. We're going to be using the one that shows the area of our body that we want to affect, also the body itself, and whether we want to update the position and rotation. So go ahead and select that one. For the area, we want to relate to our actual player or our sprite, and then we want to relate to the body of that sprite that we set up, which will be body. We want to update the position, so we're going to set that to true. And as for rotation, we probably are going to set this to false because we don't want Fred to be spinning, and it's going to make our game a lot harder to play if there's rotation involved. So as for now, we're going to set that to false. We might change it later, but that's kind of how it works. Let's save everything and run it on our emulator. And as you can see, Fred just went off of our screen because we don't have anything for him to interact with. So that's the next thing we're going to set up is a ground. And I know we are going really quickly through a lot of this stuff and it might be confusing, but trust me, just stick with the series, guys, because we're going to go over this over and over and everything's going to make sense, I promise you. So just if you're completely confused, don't worry about it for now, because we will be going over this stuff again. So let's go back up to our onCreateScene method here. Where is it? Here. And before we do our callback up here, we're going to say we want to create some walls. So let's create that method, create walls, and you can hover over and it'll create the wall for you, or at least that method. And then within here, we're going to refer to our fixture definition, and we're going to call this wall fix set this equal to, again, physics factory dot create fixture, and for our wall we want it to have a 0 density, a 0 elasticity, and a 0 friction. And again, you probably have to put F's at the end of these because it's looking for float values. You just have to make sure that you are giving a float value. The next thing that we want to do is maybe create, instead of a sprite, maybe just a rectangle from the rectangle class, and we're going to call this ground. It's going to be equal to a new rectangle. As you can see down here, it comes from the AndEngine class, the entity primitives class, which will include our rectangle that we're creating here. We need an X and a Y value, also a width and height value, and our vertex buffer, which we kind of used when we created our sprite. So go ahead and click that. For X value, we want to say like 0, because that'll be the very left edge of our screen. For Y, we might want to say screen height. And if we actually want to see our ground, we can do like -15 pixels or something like that. For our width, we want it to be the width of our screen. So again, we're going to relate to the camera width. And for camera height, maybe we'll say 15 pixels. And that way it'll go to the bottom of our screen as well. And lastly, for our vertex buffer, we're going to relate to this dot AndEngine dot get vertex buffer manager, kind of like we did with our sprite. Again, I'm not sure if I explained that or not. We'll get into that later if I haven't. And change that back to rectangle. So now we've created, again, our object, or what it kind of looks like. We might want to say our ground dot set color, and we can say a new color and give it pretty much whatever parameters you want. I'm just going to say like 15, 50, 0, some color. Again, that's up to your design, however you want it to look. The next thing that we have to do is relate to the physics factory class, and we're going to say dot create box body. And this is kind of like when we created the circle body for Fred. We're just going to say create box body. For the first parameter, what physical world or physics world do we want? We want the one that we defined. The next area that we're defining will be our ground area. It comes from the rectangle class. And then the body type, we're going to say body type dot static, because if we said dynamic like we did with Fred, our ground would fall with the scene as well, and there would be no collisions because both objects are falling at all times. So we're going to say static body for the ground, and lastly for a fixture we're going to say our wall fixture. Then the last thing that we have to do is relate to our scene, and we're going to say attach child, again our entity, which will be our ground. So let's save this and run it, and hopefully we get something like at the beginning of the tutorial. And again, if you guys were getting problems with your emulator, in the last tutorial on mybringback.com I showed you a little trick. Again, it might be your graphics card in your computer that might be causing you problems, but this is kind of how it looks. Kind of how I showed you in the beginning of the tutorial. We created a rectangle here that's static. It won't be affected by gravity. Fred is there and he bounces. If we go back down to the populate scene, you guys can mess around with elasticity. Like, let's change this to 0.2 maybe, something like that. And again, you guys can mess around with these and just experiment, because that's the best way to learn, is if you just kind of mess around. But as you can see here, it looks like he doesn't have any elasticity. He just bounced and barely went up, then bounced again, and now he's pretty much on the ground. So again, we wanted our elasticity to be 1, so he's roughly about the same height as when he bounced. And that's pretty much it, guys, for this tutorial. I know it is pretty much monkey see, monkey do, but we will learn these topics more in depth in the next few tutorials within the series, so please continue watching. Click that like button, hit the subscribe button, and share these videos with your friends, because they'll motivate me to create more of them and more quickly, all that stuff. So thanks again, guys, for watching, and we'll see you later.